Features of 8086 microprocessor. Very first feature is it is 16-bit microprocessor. Its first feature, it is 16-bit microprocessor. Now, when we say it is a 16-bit microprocessor, means its ALU size is 16-bit, then register size is 16-bit internal registers and 16-bit internal data bus. This is the simple meaning of 16-bit microprocessor. ALU size is 16-bit, means the arithmetic and logical operations are performed on two 16-bit operands, and all the internal registers. We'll discuss this internal register in detail while studying the block diagram of 8086 and 16-bit internal data bus. This is the very first feature. Now, second feature is there. That it has 20-bit address bus and can access up to 2 raised to the power 20 memory locations, that is a 1 MB memory locations. Now, what is the exact meaning of this term? Now, suppose we have 1 bit address bus. We have 1 bit address bus, and when 1 bit address bus is there, with the help of this we can address 2 raised to the power 1 equals to 2 locations. Means here the 2 maybe locations are there, one will call as 0, other will call as the 1. If there is a 2-bit address bus, then 2 raised to the power 2 equals to 4. In that case, we can address here 4 memory locations, address 0, 0, 0, 1, 1, 0 and 1, 1. Now, when similarly we have 3-bit, then 3-bit address bus, then 2 raised to the power 3 equals to 8. Here in this case, then first address is 0, 0, 0, second address is 0, 0, 1, third 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Here, this is what? This is the memory address, and here inside this the data is there, and this is memory location. This is memory location, and this is the content of memory. Content of memory. This is for 3-bit. Now, in our example, we have 20-bit address. Here, 2 raised to the power 20 comes to be 1048576, that is equals to 1 MB. Now let us discuss this with the help of simple diagram. Now this is the first location. This is the first location. This is the second location and this is the last location. Now first address is here. First address is 0000 16-bit address 000 000 This is the first address. Take the second address is this is the sorry, this is the second address, and then last address is this is last address. This way, this is from 000 to 111. This is the total. This is total 1 MB memory locations. That is a 1048576. Now this is address. This is the memory address which is in the binary form, but we require this address in the hexadecimal form when we handle these addresses in the program. That's why it is required to convert this hexadecimal to the binary to hexadecimal. Here, when we convert binary to hexadecimal, we require the group of 4 bits. Starting address is 00000, and here the H is written for hexadecimal. The second address is now second address is 00001 and so on, and the last address is F F F F F. So this is the meaning of the second point. It has 20-bit address bus, thus can access up to 2 raised to the power 20 memory locations, that is 1048576 memory locations. Now next feature is there. It can support up to 64K I/O ports. It can support 64K I/O ports. Now first we have to see the meaning of I/O ports, and then 64 means what and I/O port means what. Here we'll discuss this with the help of diagram. The meaning of now this is microprocessor. This one is interfacing device, and this is the input device, and this is the output device. Say input device is your keyboard, and here output device is printer. As we are aware, the microprocessor is faster as compared to these I/O devices, which are slower in nature. That's why some mediator is required which is called the interfacing device, to have the proper communication between the microprocessor and I/O devices. Here, whenever the input device want to transfer the data, say when keyboard want to transfer or send the data to the microprocessor, it won't directly send it to the microprocessor. Instead of that, it will send this data to this device, and then from this device it is sent to the microprocessor register. Similarly, when microprocessor want to send the data to the output device, then first it will send this to this device, and then from this it transfer to this. Here, what is this place is there here for temporary hold the data is called as IO ports. This is referred as output port, and this is referred as input port. What is IO port then? It is a place for loading and unloading of the data where the temporary the data is held by the device. Now here, since 16-bit address is there, 2 raised to power 16, 2 raised to power 16 equals to 64K, that is 65536 IO devices can be connected. When address is 16-bit. Block diagram of 8086 microprocessor, also referred as architecture of 8086. The block diagram of 8086 consists of two sub-blocks. One is referred as BRU, Bus Interface Unit, and second sub-block is there called as Execution Unit EU. Execution Unit EU. Now, what is the function of the BIU? BIU communicate with the outside world. It is very clear to memory and input-output devices, and EU perform arithmetic logical operations here. Now we'll discuss it with the help of this simple diagram. This is the 8086, consists of two sub-blocks BIU and EU. Now what BIU do? BIU get connected with the outside devices such as memory and IO devices with the help of external address, data and control bus. Now as far as this bus is concerned, address is unidirectional. And this address is always 20-bit, while data is bidirectional, and this is the 16-bit. Now, even though the data bus is 16-bit, one can transfer here 8-bit data also, or 16-bit data also is possible for this 16-bit data bus. Now, what are the various functions of the BIU? BIU handle all the external data transfer operations, such as it sent out the address of memory or IO port. It sent out the address of memory or IO port. Then it fetch the instruction. It fetch instruction from memory. It fetch the instruction from memory, or it read the data. It read data from memory or IO ports, or it write the data. Write data to memory or IO ports. These are the simple operations are performed by bus interface unit. Now what does execution unit do? Execution unit simply get the instruction from BIU, decode it, decode the instruction, and then it execute the instruction. Execute instructions. What BIU do? BIU place the address, BIU fetch the instructions, BIU read the data from memory or IO device, it write the data to the memory and IO device, EU simply read the instructions from the BIU, decode it and execute it. The same thing is mentioned here. What are the various functions of the bus interface unit? BIU is interface to the outside world. It provides full 16-bit bidirectional data bus and 20-bit address bus, which is unidirectional. And BIU is responsible for performing all the external bus operation as listed below. We have already discussed this. It send the address of the memory or IO. It fetch the instruction from memory, read the data from ports or memory. It write the data into ports or memory. It supports the instruction queuing. This we have not discussed. We'll discuss it. And it provides the address relocation facility. We'll discuss it later on. The next is the execution unit. So what it do? To test the BI, where to fetch the instructions or data from, decode the instructions and execute the instruction. Now come to the BIU. In the BIU, there is a 6-byte prefetch queue. 6-byte prefetch queue. Now, what is the function of this 6-byte prefetch queue? Whenever BIU place the address on the address bus of the memory, here BIU fetch the as far as 6 instructions ahead of execution and hold this in the FIFO first in first out queue. What BIU do? BIU prefetch the instructions ahead of the execution and hold it here in the form of first in first out queue. And then execution unit simply read this and perform the operation on that. Means when BIU is busy in fetching the instruction, execute unit execute the instructions. Both the operations are going on. That is what operation? Fetching operation is going on here and execution operation is going on here. And this feature is called as pipelining. You have already studied here. Pipeline is when the fetching and execution is going on simultaneously. So here instruction queue in 8086. It is queuing facility where the BIU fetches the 6 instruction byte from memory while current instruction is being executed. And the purpose of this is to speed up program execution. We already discussed this. It works on first in first out fashion. Queue size is maximum 6 byte. BIU fetches the instruction code from the memory, store it in the queue, and you fetches the instruction from queue for execution. Registers of 8086. Registers of 8086 are broadly categorized as general purpose registers, then pointer and index registers, and segment registers and flag registers. These are total 14 registers are there. Now these registers are broadly classified into 3 categories. Refer as data registers, namely AX, BX, CX and DX. Address registers, which are used to hold the address of instructions or data, and there are 3 types. Segment registers such as CS, DS, ES and SS. Pointer registers such as SP, BP and IP, and index registers SI and DI. And a status register, which is also called as the
flag registers. So these are total 14 16-bit registers of 8086. Now we'll discuss all those registers one by one. First we'll discuss general purpose registers. Now as far as general purpose registers are concerned, there are 8-bit general purpose registers. There are total 8-bit registers such as AH, AL, BH, BL, CH, CL, DH, DL. All those registers are 8-bit registers. All those registers are 8-bit registers, and all the registers can be used as a general purpose registers. Now when we require the 16-bit operations, then this AL and AH register together is referred as AX register. Similarly, BH and BL is referred as BX register. CH and CL is referred as CX register, and this is referred as the DX registers. This we can say that there are 1, 2, 3, 4, 5, 6, 7, 8 8-bit registers, or we can say that there are 4 16-bit registers. Now, depending upon the use of these registers are identified by the different names of these registers. This AL registers, this AL register is also called as 8-bit accumulator. AL is referred as 8-bit accumulator. 8-bit accumulator. It is referred as 8-bit accumulator, and AX register is referred as 16-bit accumulator. Now this AX register can be, or AL register can be used as a general purpose register, and it's, we can say that special purpose of this register is that it is used as a accumulator. Now what is the exact meaning that it is used as an accumulator is that, suppose you want to perform the multiplication of the two numbers, say the number 5 into 8, suppose, or 9, this multiplication we have to perform. And when this multiplication has to be performed, then out of the two numbers, one number must be in the AL registers and the other number can be in the any other register, say such as the BL register. Then the multiplication of these two numbers is performed and the result is stored in the AX register. For this type of the operation, means such as the multiplication is there, division is there, then the BCD addition is there, for such operations the AL or AX register is must. That's why this is also referred as the accumulator, and this is the special purpose of this register. Is it clear? This is AH and AL together is called the AX registers. All these registers can be used as a general purpose register, while the special purpose of this register is that AL register is called as the 8-bit accumulator and AX register is called as the 16-bit accumulator. So these registers are must in certain operations, or we can say that with respect to these registers only the certain operations are performed. For example, we have seen that when we require to perform the multiplication of two numbers, then one number must be in the AL register and the second number in the BL or any other register. There is no any condition for the second operand, and the result is stored in the AX register. So this is the special purpose of AL or AX registers. This is just one example. We'll discuss this more while studying the instructions of 8086. Then this register, that is another register, which is the BX register, which is also called as the base registers. BX register is called as the base register. Now again, these registers, that is a BH, BL and a BX, can be used as a general purpose register. But the special purpose of this BX register is that, this is the only register. BX is the only register from these four registers, only register which is used or which can be used as memory pointer. Out of these registers, the BX register is the only register we can be used as a memory pointer. Now what is the exact meaning of the memory pointer and how it is used as a memory pointer? Suppose I have the one memory location is there. Say this location is 2500 is the memory location, and at this memory location one number is presenting, say, the 55, and I want to transfer this number, say, in the AL register. What operation we have to perform? One memory location is there. This is the memory location 2500, and at this memory location one number is 55, and we have to transfer this in the AL register. So how this operation can be written as move AL comma in bracket 2500, means transfer the data from the memory 2500 in the AL register. Now if I put this 2500 in the BX register, 2500 in the BX register, the operation is written as move AL comma bracket BX. What it means? It means that transfer the data from memory pointed by BX register in the AL registers. Means in this case, the BX register, this we can say that this is the memory and this is the register. Transfer the data from memory to registers. So for such operations, the BX register is used to hold the address of the memory. It is used to hold this. This is held by the BX registers, and this is the meaning of the term memory pointer. So out of these four registers, means AX, BX, CX and DX, only the BX register can be used as a memory pointer. Is it clear? First we have discussed, this is the accumulator. AL is the accumulator. AL is the 8-bit accumulator while AX is the 16-bit accumulator. Second is the base registers. BX is called as the base register, and this is the only register which can be used as a memory pointer. And meaning of the memory pointer, we have discussed that. Here if the memory location 2500 is there and content of this 2500 is 55, which has to be transferred in the AL registers. This operation is specified like this: move AL comma 2500, means transfer the data from memory 2500 to the AL registers, means in this case this 55 in the AL registers. So here the same operation can be written as get this address in the BX register, and then it is written in this format, the move AL comma bracket BX. Then BX register is used to hold, address of memory. So this is the special purpose of BX register. Next is the CX register. This CX register, again data registers, but its special purpose is that it is used as a counter. Now when there are the loop operations, when there are the loop operations, when there are loop operation, you already studied the for loop, correct na? And all these type of the loops here. Similarly here, suppose I have to perform some operation we have to perform 5 times, some operation 5 times. In that case, in the CL register, 5 is taken and then it is decremented, and here by default there are the certain instructions such as the loop instructions which decrement the content of CL or CX registers and automatically transfer the program control to the back from where it is back. So here, that's why this is called as the counter registers. So here, AX register, accumulator. Then BX register is the base register which is hold the address of memory. CX register is used as a counter. Next is the DX register. This DX register is also called as the data register. It is also called as the data register. Now what is the special purpose of this DX register? What is the special purpose of DX register? Now this DX register is used when there are the operations such as the multiplication, when there is a 16-bit by 16-bit multiplication, then product is 32-bit. When this type of the operations are there, then whatever the product is there, this product is always in DX and AX register. We suppose this is the 16-bit in the AX register, this is in the say BX register, then operation is there multiply AX with BX, then what is the result is there, the result is in the DX and AX, means upper 16-bit of the product are there in the DX registers. Or when there is a when there is a 32-bit by 16-bit division, when there is a 32-bit by 16-bit division, then the dividend must be in DX AX register and the divisor can be in any other register. So what is the function of DX register here? When division is there, upper 16-bit of the dividend must be in the DX register. Then we get quotient in AX register and remainder in the DX registers. This is the special purpose of DX register. So here, what we have discussed now? We have discussed that there are 8-bit general purpose registers such as AH, AL, BH, BL, CH, CL, DH and DL. These are the 8-bit general purpose register. This together is called as the AX register, this together is called a BX register, this together is called as CX register, and this is called as the DX registers. Now 8-bit AL register, that is called as the 8-bit accumulator, while the AX is called as the 16-bit accumulator. Then BX register is called as the base register, which is used to hold the address of the memory. CX register special purpose is that it is used as a counter when there are the loop operations, and DX register is used to hold the upper 16-bit of the product when there is a 16-bit by 16-bit multiplication, and it is used to hold the upper 16-bit of the dividend when there is a 32-bit by 16-bit division, and remainder is in the DX registers. These are the functions of these AX, BX, CX and DX registers. Next we have to discuss the segment registers of 80. 8086. Next we have to discuss segment registers of 8086. Now in order to discuss the segment registers of 8086, first we require to discuss the concept of memory segmentation in 8086. We have to discuss the concept of memory segmentation in 8086. Now, what is this concept of memory segmentation? Memory segmentation. Now, as we are already aware that total memory that is accessed by 8086 is 2 raised to the power 20 equals to 1 MB, that is equals to 1024K. Now this total memory of 8086 is divided, this total memory of 8086 is divided this memory is divided into block of 64K. Memory is divided into block of 64K means total is 1 MB. This total 1 MB memory is divided into the block of 64K, and if 1024K divided by 64K, it comes to be total 16 blocks. Here in the concept of memory segmentations, total 1 MB memory is divided into the 16 segments. Now depending upon the use of these segments are identified by the different name, such as core segment, then stack segment, data segment, and extra segment. Memories divided into this total 1 MB memory is divided into the block of 64K called as the core segment, stack segment, data segment, and extra segment. Now this total covers only 256K out of 1024K. So to cover total 1024K, there are the similar more segments are there. Means for example, we can say that a core segment 1 is there, then core segment 2, means 4 core segments are possible, then 4 stack segments are possible, 4 data segments are possible, and 4 extra segments are possible to have the total 16 segments. Now, what is the function of these segments? This core segment is used to store program. It is used to store the program. Means program codes are stored here. Then stack segment is used to store intermediate results or the return addresses For that purpose this is used. Then the data segment is used to store the data, and extra segment is also used to store the data. What is the special use of this extra segment? We'll discuss it later on. So what we have discussed up till now? We have discussed that total 1 MB memory is divided into the block of 64K. Now as far as these blocks are there, suppose this address is 0, 0, 0, 0, 0. This is starting address, we can say that. And then so on, these addresses go on. For example, now this address is 2000. Then this is the 64K. What should be this address? This is called the starting address and this is called the ending address. So what should be this address now? 20000 plus FFFFF, that is equals to 2FFFFF. This is the ending address of this. How we get this? This is the 2FFFF. As far as this block is concerned, as far as extra segment block is concerned, this is 200, this is 2FFF. Because this is 64K and 2 raised to power 16 comes to be 64K. That's why as far as this block is concerned, this address is from 0000 to FFF. 00 to FFF. That's why we have added FFF to this and we get this address. Now, what is this starting address of this data segment? It is 2FFF plus 1. It comes to be 30000. So here it is 30000 is the starting address of this. Then ending address of this is 3FFF FFH. Then the next segment is there, which may be 400. Then you see the 4FFF and so on. So this way these addresses are calculated. Now we'll focus to the only one segment and we'll discuss it in the detail. Now suppose we have a code segment, Now starting address, for example 2000, ending address is 2FFFF. This is the code segment, or I'll write it here. This is code segment. What is the size of this? This size is of 64K. As far as this code segment, for example, we have taken this. We'll discuss about the other segment also the similar way. So here 200, this is called as base address. This is called as the base address, also called as the starting address. And then this is the ending address. Now this is the how many bit address? This is the 20 bit address, which is called as the physical address also. Now as far as this 64K block is concerned, this is the starting address 0000 and this is the ending address FFF. F, F, F. This is the FFF as far as this is concerned. Now we have to discuss the function of segment registers with respect to this diagram. Now in the diagram we already discussed that there are the various segment registers such as code segment, stack segment, data segment and extra segment. So here we have two terms, 8086 microprocessor, and this 8086 microprocessor contains the registers such as CS, then DS, SS, ES. These registers are there in 80. These are the registers in 8086. All those are 16-bit registers. All those are how many bit registers? These are the 16-bit registers. And we have memory. We have the memory with various segments such as code segment, stack segment, data segment and extra segment. Generally we get confused with these two terms, this term, and we get confused with this and this. So we have to remember that these are the registers which are in the 8086 and these are the segments which are the part of the memory, or we can call these are the memory segments. Now what is the function of these registers? We will discuss for the CS register. In our case, the address is there. This is the starting address is 2000 and ending address is 2FFF. So what this CS register do? CS register hold upper 16-bit, it hold the upper 16-bit of starting address or the base address of code segment registers. Means in our case, CS register hold what? CS register hold address 2000. CS register means here this is a CS register. This CS register will hold address 2000, which is the starting address of, which is the upper 16-bit of the starting address of the code segment, which is here. Now, as far as this 64K is concerned, suppose there is any instruction here. This any instruction is here. Say with respect to this instruction is at the address 40000. You are getting it? Here, as far as this 64K is concerned, this is the starting address 000 and this is the ending address FFFF. As far as this 64K is concerned. Now any instruction is there and this instruction has to be read by the microprocessor. With respect to this address, it is as address 4000 and this address is held by IP, that is a instruction pointer. Here in this case, instruction pointer equals to what? 4000. Instruction pointer is 400 and CS is 200. But when processor has to read this instruction, processor will require this address. Processor required this address and this address must be how many bit? This address must be the 20-bit address. To read this out, read it, the processor required the 20-bit address. But here we have the two addresses, CS equals to 200, IP equals to 400, and using these two addresses, the 20-bit address is calculated.